Hi students, welcome to this video session. I remain Samuel Chukwu Emeka, aka Sam Dump for Peace. In this video session, we shall discuss the interpolation method, and one of the uses of the interpolation method. We shall discuss this use in algebra. We shall do more uses of the interpolation method in subsequent videos. Let me open a new section and I will call this interpolation method. This is my notebook. So I'm gonna call this page, I will call it a interpolation method part 1. Part 1. We shall have other parts, but I want to use this part to illustrate one of the uses of the interpolation method in algebra. So temperature conversion. This is a Celsius Fahrenheit conversion. So you know that the formula, like let's say you have a friend in Nigeria or in Britain, and you are here in the United States, and you want to know what temperature is over there, because Americans will use the Fahrenheit temperature, while other countries use the Celsius temperature. So let's say you want to convert the temperatures. So you may be familiar with this formula. I'm going to write this. You may be familiar with this formula that F minus 32 over 9 equal to C over 5. Okay, where your F is the Fahrenheit temperature and your F, degree F, degree F is the Fahrenheit temperature. And your degree C is your Celsius temperature. So, but have you ever wondered how they got this formula? We are going to look at that. One of the uses is the interpolation method. I chose to do this first use in algebra. I will do at least 2 other uses in statistics. It is very, very important in statistics, this method. So what is interpolation method actually? So let's say you have a chart, a chart that has 2 variables, and it has the values of those variables. Let's say the Celsius Fahrenheit chart. Let's say you are working in a medical facility and you have a Celsius Fahrenheit chart. Okay, maybe a chart that looks like this. Let's say you have I'm gonna use double lines to kind of demarcate what I'm talking about. So let's say maybe here you have the Celsius, and maybe here you have the Fahrenheit. Something like a chart, degree Celsius and degree Fahrenheit. So you have several values. Let's say you have several values of which one corresponds to which one. A a temperature of this in Fahrenheit will be a temperature of what in Celsius. Something like that chart. And you probably don't have a particular value on this chart. Let's say this chart, maybe let's say you have for the Celsius, maybe let's say you have it as 5, 10, 15, 20, 25. Let's say you have 5, 10, 15, 20, 25, 30, 35, 40. Okay, so if you want to find something like 37, for instance, 37, that is not on the chart. Okay, if you don't have the whole values on the chart, which sometimes you wouldn't have anyway, if not for this chart, you will see that typically in other charts that you interpret. If you're a nurse, or if you work in the medical field, or if you are a scientist or even an engineer reading charts, sometimes you don't find the exact value of a chart like the 37 degrees Celsius, which is the human body temperature. Okay, the human body temperature is about 37 degrees Celsius. So let's say you found 35 and you found 40. Okay, but you didn't find 37. You didn't find 37. Okay, now how are you going to read? How are you going to get the value for 37? So that is what we mean by interpolation. You have to interpolate between two values. You're looking for a value based on several other values that are there. So you have to interpolate between two values in order to find the value for 37 that you want to. Okay, so if you don't have this typical in this chart, you will see it severally in statistics, whereby you have a chart, let's say the normal distribution table, and you are looking for a critical value of z, and you don't see the probability or the area in that chart. How would you find the z? That is the interpolation method. But I just wanted to at least do this in algebra to also verify this formula. Okay, we shall also verify this formula. Then I will now do the rest in statistics. I will now do some of the other ones in statistics. So let's say now, let's start with, you have the 37 degrees Celsius. How would you find the temperature in Fahrenheit? Okay, so what we are going to do now, I'm going to have I'll add another page, and I'll call this part 1 continued. Part 1-1, part 1-1, how about it? Okay, so let's now do the interpolation. So let's call this the Celsius, degrees Celsius, and let's call this our degree Fahrenheit. So of course, in every chart, okay, in every chart you would, for it, typically you will have 0 and you will have 100 here. 0 degrees Celsius and 100 degrees Celsius. Then you want to find that of 37. 37 is not there on the chart. Let's say it is not there on the chart. But you have 0 degrees Celsius, you have 100 degrees Celsius. And then you come to the Fahrenheit section. And of course, 0 degrees Celsius corresponds to 32 degrees Fahrenheit. And 100 degrees Celsius corresponds to 212 degrees Fahrenheit. You now want to find what Fahrenheit temperature corresponds to 37 degrees Celsius. So you put X here. You put X. Okay, so this means you are interpolating between these two values so that you can find a value here that corresponds to this 37, which you do not see on the chart. So the interpolation method we now see will be, you do 37 minus 0 over 100 minus 0 equal to x minus 32 over 212 minus 32. Okay? So 37 minus 0 gives us 37 over 100 minus 0 gives us 100. And this will give us x minus 32 over 2 minus 2 is 0, 11 minus 3 is 8, 1. 212 minus 32 gives you 180. So we can now do cross product. Okay, we can do cross product, cross multiply. So 100 times x minus 32 will give us 37 times 180. Okay, now what we did was we just did cross product. That was what we did, cross multiply, because you have an equation. So we just, you have an equation that has just one term on each side. So we just did cross product. This is x. So you divide both sides by 100. We have that x minus 32 will give us 37 times 180 divided by 100. Okay? So our x will be 37 times 180. You add 32 to both sides. Okay? 37 times 180 divided by 100 plus 32 plus 32. So what does our x give us now? What does it give us? I'm doing videos, so and I don't need to waste a lot of time on this. Okay, I get my calculator here. 37 times 180, you do equal to 6660 divided by 100 equal to 66.6 plus 32. 98.6 Fahrenheit. So this gives us 98.6 degree Fahrenheit. So that gives you the answer. That is how you do that. Interpolation. Interpolating between the two values. Okay? Now, what if we don't have, now, like I said, I want us to verify this. I want us to derive this. Okay? That is the essence of this also. Part of it is to derive this formula. You probably are aware of this formula, but then have you asked yourself, how did we get this formula? Okay, so I add another page. I will just say part 1-2. So here I will get my pen. So this is my Celsius chart. So you know now that human body temperature is 37 degrees Celsius or 98.4. You know, some textbooks will say 98.4. Some will say 98.6 degree Fahrenheit. So let's now derive the Celsius Fahrenheit formula. Let's verify that. Okay, so we have 100 here. We have 0. 0 corresponds to 32 degree Fahrenheit, and 100 corresponds to 212. So let's call this our C. Let's just call this C, and let's call this F. Okay. So we use interpolation. Okay. So we have C minus 0 over 100 minus 0. So that is the way we do it. Interpolation, we do this minus this over this minus this equal to F minus 32. F minus 32 all over 212 minus 32. 212 minus 32. Okay. So C minus 0 is going to give you C all over 100 minus 0 will give you 100 equal to F minus 32 over 212 minus 32 is 180. Okay, this is what we actually want to prove here. F minus 32 over 9 equal to C over 5. So we are just going to, let's swap. Swapping means let your left hand be your right hand, and let your right hand be your left hand. So if we swap, the right hand side will now be the left hand side. Equal to C over 100, and the left hand side becomes the right hand side. Okay. We have to simplify this 180 and 100, you know, because we got the top part, we got the numerators of both fractions, but the denominators, we have to simplify it. So let's look for the greatest common factor of 180 and 100. Okay, let's look for the greatest common factor of 180 and 100, and we can just multiply. We can multiply both sides by the greatest common factor. So you still recall how you get your greatest common factor? You do prime factorization. But here, you know, I know that 10 is a common factor right away. I can find the other common factors. So even if I can do 10 times 10 here, I do 10 times 18 here. Because I know that 10 is the common factor of both of them. Then I need to simplify these two more. So this will give me 10 times 2 times 5. And this will give me 10 times 2 times 9. So what is my greatest common factor? So the common factors are 10 and 2, which is 20. So the greatest common factors, you know, I just bring out one of each. I bring out one of these, and I bring out one of these. Those are the greatest common factors. So 10 times 2. 10 times 2, and that gives you 20. So what I will do now is to multiply both sides by 20, and it is still okay, because this is an equation. Whatever you do to the left hand side, you also do to the right hand side. So I'm going to call this part 1, 3. So I finish it up. So I multiply 20. I multiply both sides by 20. So 20 times f minus 32 over 180. Because this is actually, why we do this is to kind of simplify it so that you don't work with many numbers, you know. You don't work with many numbers. 20 times c over 100. Because imagine if this was just the formula here. You would be working with 180 and 100. Come on. When you could easily simplify it, make your life easier. work with simple numbers, okay? So 20 into 20 is 1. 20 into 180 is 9. 20 into 20 is 1. 20 into 100 is 5. So we have that f minus 32 over 9 equal to c over 5. And of course, this is your Fahrenheit Celsius temperature conversion formula. Okay, Fahrenheit Celsius temperature conversion formula. Okay, thank you so much for listening to this video session. We will do at least part 2 and part 3 of this interpolation method will be focused on statistics. So please watch out for the other videos. I will put those on my website. Thank you for listening, and you have a great evening.